Okay, so section 5.6 and 5.7 is going to be split up into two parts. The first part is finding zeros. So we've already found real zeros in the previous sections. Now we're going to figure out how to find all zeros. All right, so this comes from standard 5 or F6. I can find all zeros of a polynomial function. All right, so first recall the quadratic formula. We are going to need to know that. So x equals the opposite of b plus or minus b squared minus 4ac, that's the square root of that, all over 2a. All right, also recall the fundamental theorem of algebra, which says if f of x is a polynomial of degree n, where n is greater than 0, then the equation f of x equals 0 has exactly n solutions, provided each solution repeated twice is counted as 2 solutions, each solution repeated 3 times is counted as 3 solutions, and so on. All right, so we've already talked about this. You may have not known what it's called, but if we look at example 1 here, it says how many solutions do the following equations have? So we have 2x to the 5th plus 4x to the 4th minus 3x squared minus 7x plus 11 equals 0. All right, we already talked about looking at the degree. The degree gives you the number of solutions. So since this is x to the 5th, this first one gives us 5 solutions. All right, looking at the second one, the degree is 4, so we're going to get 4 solutions. And the third one has 3 solutions. All right, a couple definitions that we need to talk about. The solutions to equations are also called the roots of the equations. Solutions are also called zeros of a function. And if solutions are real numbers, then those solutions are x-intercepts. All right, solutions to equations can also be imaginary, so roots can also be imaginary. Zeros of the function can be real or imaginary, but x-intercepts by definition are real, not imaginary. If you think about x-intercepts, if we're graphing them, they have to show up, so they have to be real. We can't graph imaginary numbers. All right, so to summarize that all up, we can take solutions, roots, and zeros and interchange those. They all mean exactly the same thing because they can all be real or imaginary. However, x-intercepts can only be real. Okay, and one last thing to note, if a problem asks for all real roots, then you disregard any imaginary roots. We've already seen problems like that. But if a problem asks for all zeros or all solutions, then your answer should contain real and imaginary solutions, if they exist. All right, let's take a look at some examples. All right, so we are going to find all zeros of the polynomial function. So the first example is x cubed plus 5x squared minus 4x minus 20 equals 0. So we could do this one of two ways. All right, this we've kind of already done before, except now we're going to probably have imaginary, or we possibly could have imaginary numbers. All right, so first of all, you can go ahead and use your calculator to find them. So I'm just going to talk you through this. All right, so you're going to put in your calculator y equals, so go ahead and get your calculators. Pause it if you don't have them. All right, so go ahead and try this. So you're going to put in y equals x cubed. Then you're going to put in plus 5x squared. Then you're going to put minus 4x. And then you're going to put minus 20. Okay, again, make sure it does say equals if you have the inequalities program turned on. All right, go ahead and zoom 6 and graph it. All right, and you should get something that looks similar to this. All right, well, let's talk about the equation first. If we look at the function, how many solutions does the function have? Well, because it's x cubed, that's the highest degree, then there are 3 solutions. So if you look here, all 3 solutions show up in the graph. So we can go ahead and use that. Now, instead of finding the intercepts, we're going to go ahead and use the table feature. All right, so go to second graph, which gives you the table. And remember, x-intercepts occur when y is 0. So we can go ahead and find the answer every time y is 0. So we're going to have to scroll through the graph. All right, let's all start at, well, if you look around -5. All right, -5 is our first x-intercept, or our first 0. Okay, if you scroll up from -5, you'll notice those numbers go higher, higher, higher. So there's going to be no more x-intercepts up there. If we scroll back down, all right, I'm at -5, 0 right now. If I keep scrolling down, you'll notice that there's another 0 at -2. All right, keep scrolling down again, and we hit another 0 at positive 2. All right, keep scrolling down again, and you'll notice that they get bigger and bigger and bigger. So there's going to be no more solutions. All right, so our answer is -5, -2, and 2. I know I've hit them all because the degree was 3. All right, we can also use algebra to find them, which we've already done, but just a little refresher. X cubed plus 5x squared minus 4x minus 20 equals 0. We can go ahead and factor this by grouping. So I'm going to go ahead and break them up. First two I could take out an x squared. I'm left with x plus 5. Second two I can take out a 4, -4. I'm left with x plus 5. So now we have x squared minus 4, x plus 5 equals 0. I could break out this up further into x plus 2 and x minus 2. Okay, so you'll notice again, if I set each of these equal to 0, I get -2, +2, and -5. Same exact solutions. Okay, so there are two ways to do it. Now that only happens when the answers are real. All right, if there were more imaginary numbers, you couldn't do it that way, and that's what we're going to take a look at next. Okay, so just to give you a heads up, now you could factor this problem, but I'm going to show you the more difficult way with an easier problem, and then we'll get to a little bit more complicated problem. All right, so here are the steps when you can't factor or you can't solve a different way. All right, first you're going to use your calculator to find any rational zeros, so anytime you have an x-intercept. So go ahead and put this in your calculator, go to y equals, clear that out. You're going to put in x cubed, then plus x squared, then minus 3x, and then minus 3. Okay, you can go ahead and graph that just to make sure that you're on the right page here, and you should get something that looks like this. It goes up, it goes down, and it goes back up. All right, but we want to know what the intercepts are. All right, we know that we have 3 answers, but let's see. So now you go to the table feature, so second graph. All right, I am at a positive 13, so if I scroll down, I notice the numbers get bigger and bigger. So I'm going to have to scroll back up and see where y equals 0. All right, and I see that y equals 0 at -1. And if I keep scrolling up, the numbers get bigger and bigger and bigger. Well, smaller, smaller, actually. All right, so I know I'm not going to have another one. So -1 is my only solution. I need 3 solutions. All right, so what I'm going to do now is I'm going to use synthetic division to get the x cubed down to something we can solve by either factoring or the quadratic formula, like an x squared term. All right, so I'm going to go ahead and do synthetic division. I'm going to take the -1. Now I don't have to switch the sign because it's not in parentheses. All right, that's the actual solution. And I'm going to divide 1, 1, -3, and -3. Don't forget to use a 0 if you are missing a term. All right, now synthetic, we're going to bring down the 1. We have -1 times 1 is a -1. Go ahead and add down, we get 0. Now -1 times 0 is 0. Add down, we get -3. And -1 times -3 is +3. And add down, we get 0. Now this remainder always has to be 0. If not, you did something wrong. So go back and check your work. All right, this is my constant, this is my x, and this is my x squared. So now we have x squared minus 3 equals 0. We know how to solve that, so let's go ahead and solve it. First, we're going to add 3 to both sides. We get x squared equals 3, and then we're going to take the square root. So x equals plus or minus the square root of 3. All right, so there are my 3 answers. -1, a positive square root of 3, and a negative square root of 3. All right, let's take a look at another one.